Hello everyone, I'm Mi Ping, come from School of Basic Medical Science, Shandong University. Here I would introduce and share some of my researches during my doctorate study. The work I did is about the effects of fluorine non-bisphony on development and sleep-wake behavior of zebrafish. The experiment contains 5 parts. In this reporting, I will focus on the first 2 parts. The content is divided into 4 sections. First of all, I will introduce the background of this study. Endocrine disturbing chemicals can mimic, block, or interfere with hormones in the body's endocrine system. Endocrine disturbing chemicals can interfere with biological production, development, behavior, and hormone synthesis. So endocrine disturbing chemicals is common in our life. In fact, endocrine disturbing chemicals are found in many everyday products as well as industrial products, such as pesticides, metals, pharmaceuticals, industrial ingredients, solvents, ingredients in household products, and materials in central. A lot of previous reports and studies showed that it can induce developmental toxicity, carcinogenic, and teratogenic effects. Therefore, endocrine disturbing chemicals have been associated with a diverse area of health issues. Bisphenol A, also called BPA, is one of the most well-known endocrine disturbing chemicals. BPA is widely used in plastics, flame retardants, heat stabilizers, and other chemical products. For example, BPA is added in many commercial products, including food and beverage packaging, milk bottles, water bottles, and other daily necessities. Bisphenol A has an estrogen-like effect, which can cause varying degrees of damage to the reproductive system, and a lot of studies have shown that BPA have certain embryotoxicity and teratogenicities. Therefore, many countries and regions have restricted the application of BPA in milk bottles, water cups, food packaging, and other products. As we can see, some plastic products with the word BPA-free. It's worth noting that many BPA-free products have merely replaced BPA with bisphenol S or bisphenol F, also called BPS and BPF. However, even small concentrations of BPS and BPF may disturb body function in a way similar to BPA. And therefore, BPA and its alternatives, BPS and BPF, may be found in many commonly used products. In this case, other substitutes of BPA are applied. Industrial manufacture, fluorine non-bisphony, also called BHPF, is one kind of BPA substitute. BHPF is widely used in the production of plastics, such as epsom resin, polycarbonate, polyester, polyether, and thermal recording materials. The application of BHPF could increase the heat resistance and transparency of the products and improve the product performance. The use of BHPF is also increasing recently. However, the biological function of BHPF and the potential risks are unclear. Like BPS and BPF, BHPF is also the structural analog of BPA. Considering the adverse effect of BPA alternatives of bisphenol, BHPF may be a potential
endocrine disturbing chemical.
Therefore, it is significantly important to learn the bisphenol effects of BHPF. Zebrafish is one kind of small freshwater fish that originate from Southeast Asia. The figures show the historical and more recent sites where zebrafish have been reported in India, Nepal, and Bangladesh. Zebrafish is characterized by several blue and silver stripes on each side. The body length of the adult zebrafish typically ranges between 3 to 4 centimeters. As a model organism, zebrafish have many advantages, such as large egg production. One adult female zebrafish lay up to several hundreds of eggs per spawning. This picture showed the eggs produced by one pair of zebrafish one time. You can see that they have lots of siblings. Therefore, the large egg production provides an ample supply of embryos to study. Another advantage is that zebrafish embryos has a very quick rate of development. Zebrafish grows at an extremely fast rate, developing as much in one day as a human embryo develops in 1 month. Another advantage is that fertilization and development in vitro. Zebrafish eggs are fertilized outside the mother's body. It makes it an ideal organism for studying early development. Besides that, you can see the zebrafish embryos is transparent. The body is relatively transparent during the larvae development stage, which provides excellent optical clarity, making them a practical choice to easy observation. Another advantage is that zebrafish is genetic similarity to humans. The homology of genome between zebrafish and human is about 70%. Approximately 80% of the genes involved in human disease have an equivalent in zebrafish. Due to the good characteristics the zebrafish genes, it is possible to target special genes, turn them on or off, or introduce foreign genes. This makes zebrafish very versatile for gene operating. As a consequence, nowadays zebrafish is recognized as an ideal model organism for investing developmental biology, genetics, neurobiology, environmental toxicity, and other research fields, as well as for the disease model construction and drug screening. In this case, I conducted my study about the effect of BHPF by the zebrafish model.